This is Miss Passowit coming to you live from Supreme Science. All right, here we are with Supreme Science. This is my physics wall. As you can see, the father of physics, Sir Isaac Newton, very important. I don't know why South Carolina wants you to know the law of inertia and the law of action-reaction, but not his second law. Don't know why. All right, so Newton's got a bunch of laws, and this is just my way of helping my students visualize and remember these important things. So over here, we start with our position time graphs. So basically, if the graph is going up, you're moving really fast. If the slope is low, moving slow. If you have a flat line, not moving, standing still. I know a lot of students think that you're just moving at a constant speed. No. And moving backwards is if it's sloping down the opposite way. Want to hear a chant? Here's my first chant. Low slope, moving slow. The steeper the slope, the faster it goes. Flat slope, stop, no motion. Backward slope, heading home with no commotion. 8th graders, they'll do anything for a skittle. I promise. They'll sing it. They will. Sometimes I do boys against girls. Whatever works. All right, so then we've got the definition of motion, definition of speed. Average speed. Average speed starts with a V. D over T is all you need. Take the distance, divide by time. Calculate speed and even rhyme. They'll sing it, I promise. All right, balanced, unbalanced forces. The arrows are pointing towards each other. You are going to subtract these numbers. If the arrows are pointing towards each other, even if it's up and down, you're going to subtract them from each other. If they're pointing in the same direction, you add them up. These would be unbalanced. Even if they're pointing on the same side, add them up. If they're pointing away from each other, subtract. Opposite sides, you subtract. You want to hear my chant? Here we go. I don't know if I'm going to be able to remember it right now. Arrows in the same direction get added up without correction. Arrows pointing towards each other get subtracted one from another. Arrows pointing away is okay, but they get subtracted anyway. All right, so let's look at, okay, we got Darth Vader up there, Force. May the Force be with you. Lots of Star Wars fans, including my videographer, who's taking this video right now. All right, then we get to, oh yes, action reaction. We go outside and shoot off stomp rockets. One of my very favorite labs. Kids love making them, and if you want directions, you can check out one of my other videos to learn how to do the stomp rocket lab. Here are force and mass and how shape and different things affect those. These little yellow things, I always put up my standards. This almost helps me remember more than it does my students, so I don't have to go back and keep flipping through a lesson plan notebook. I can just look up here and be like, oh yeah, that's what I need to remember. So just wanted to introduce you to my physics wall. You can check out my other videos for my entire classroom, kind of like gallery walk to see all of my walls and posters. 8th grade, middle school is what I teach, and this is Supreme Science with Miss Passowit.